7. We're at part 7.
What's going to happen is, especially when you have humanoid robots at scale, is that they will make products and provide services far more efficiently than human corporations. So amplifying the productivity of human corporations is simply a short-term thing.
So you're expecting fully digital corporations, rather than like SpaceX becomes part AI and so.
I think there'll be digital corporations, but look, some of this is going to sound kind of doomerish, okay? But I'm just saying what I think will happen. It's not meant to be doomerish or anything else. Just like this is what I think will happen. Is that pure AI corporations that are purely AI and robotics will vastly outperform any corporations that have people in the loop. So you can think of, say, like computer used to be a job that humans had. You would go and get a job as a computer where you would do calculations, and they'd have like entire skyscrapers full of humans, like 20, 30 floors of humans just doing calculations. Now that entire skyscraper of humans doing calculations can be replaced by a laptop with a spreadsheet. That spreadsheet can do vastly more calculations than an entire building full of human computers. So you can then think about, okay, well, what if only some of the cells in your spreadsheet were calculated by humans? Actually, that would be much worse than if all of the cells in your spreadsheet were calculated by the computer. And so, really, what will happen is the pure AI, pure robotics corporations or collectives will far outperform any corporations that have humans in the loop. And this will happen very quickly.
Speaking of closing the loop, sorry, Optimus. As far as like manufacturing targets and so forth go, your companies have sort of been like carrying American manufacturing of hard tech on their back, but in the fields that you are, Tesla's been dominant in, and now you want to go into humanoids. In China, there's entire dozens and dozens of companies that are doing this kind of manufacturing cheaply and at scale, and are incredibly competitive.
Mm-hmm.
So give us sort of like advice or a plan of how America can build the humanoid armies or the EVs, etc., at scale and as cheaply as China is on track to.
Well, there are really only 3 hard things for humanoid robots: the real world intelligence, the hand, and scale manufacturing.
Yeah.
So I haven't seen any even demo robots that have a great hand, like with all the degrees of freedom of a human hand. But Optimus will have that. Optimus does have that.
And how do you achieve that? Is it just like right torque density in the motor? Like what is the hardware bottleneck to that?
Well, we have to design custom actuators. Basically custom designed motors, gears, power electronics, controls, sensors. Everything had to be designed from physics first principles. There is no supply chain for this.
And will you be able to manufacture those at scale?
Yes.
Is anything hard except the hand from a manipulation point of view, or once you've solved the hand, are you good?
From an electromechanical standpoint, the hand is more difficult than everything else combined. Human hand turns out to be quite something. But you also need the real world intelligence. So the intelligence that Tesla has developed for the car applies very well to the robot, which is primarily vision in. But the car takes in more vision, but also it is listening for sirens. It's it's taking in the inertial measurements. It's GPS signals, a whole bunch of other data, combining that with video. It's primarily video, and then outputting the control commands. So your Tesla is taking in 1.5 gigabytes a second of video, and outputting 2 kilobytes a second of control outputs, with the video at 36 hertz and the control frequency at 18.
One intuition you could have for when we get this robotic stuff is that it takes quite a few years to go from the compelling demo to
Yes.
actually being able to use in the real world. So 10 years ago, you had really compelling demos of self-driving, but only now we have Robotaxi and Waymo and all these services scaling up. Shouldn't this make one pessimistic on, say, household robots? Because we don't even quite have the compelling demos yet of, say, the really advanced hand.
Well, we've been working on humanoid robots now for a while. So I guess it's been 5 or 6 years or something like that. And a bunch of things that we've done for the car are applicable to the robot. So we'll use the same Tesla AI chips in the robot as the car. We'll use the same basic principles. It's very much the same AI. You've got many more degrees of freedom for a robot than you do for a car. But really, if you just think of it as like a bit stream, AI is really mostly compression and correlation of 2 bit streams. So for video, you've got to do a tremendous amount of compression, and you got to do the compression just right. You've got to compress ignore the things that don't matter, and you don't care about the details of the leaves and the tree on the side of the road, but you care a lot about the road signs and the traffic lights and the pedestrians, and even whether someone in another car is looking at you or not looking at you. Like some of these details matter a lot. So, but it is essentially it's got to turn that with the car. It's got to turn that 1.5 gigabytes a second ultimately into 2 kilobytes a second of control outputs. So many stages of compression, and you got to get all those stages right, and then correlate those to the correct control outputs. The robot has to do essentially the same thing. And you think about what humans, this is what happens with humans. We really are photons in, controls out. So that is the vast majority of your life has been vision, photons in, and then motor controls out.
Naively, it seems like between humanoid robots and cars, the fundamental actuators in a car are like how you turn, how you accelerate, etc. Where in a robot, especially with maneuverable arms, there's dozens and dozens of these degrees of freedom. And then, especially with Tesla, you had this advantage of you had millions and millions of hours of human demo data collected from just the car being out there, where you can't equivalently just deploy Optimuses that don't work and then get the data that way. So between the increased degrees of freedom and the far sparser data,
Yes. That's a good point.
How will you use the sort of Tesla engine of intelligence to train the Optimus mind?
Now you're highlighting an important limitation and difference between cars. It's like we do have, we'll soon have 10 million cars on the road, and so it's hard to duplicate that massive training flywheel. For the robot, what we're going to need to do is build a lot of robots and put them in kind of like an Optimus Academy, so they can do self-play in reality. So we're actually pulling that out. So we're going to have at least 10,000 Optimus robots, maybe 20 or 30,000 that can do that are doing self-play and testing different tasks. And then the Tesla has quite a good reality generator, like a physics accurate reality generator that we made this for the cars. We'll do the same thing for the robots, and actually have done that for the robots. So you have a few tens of thousands of humanoid robots doing different tasks, and then you can do millions of simulated robots in the simulated world, and you use the tens of thousands of robots in the real world to close the simulation to reality gap, close the sim to real gap.
How do you think about the synergies between XAI and Optimus, given you were highlighting, look, you need this world model, you maybe want to use some really smart intelligence as the control plane, and so maybe Grok is doing the slower planning, and then the motor policy is at the lower level. Yeah, what will the sort of synergy between these things be?
Yeah, so you'd use Grok would orchestrate the behavior of the Optimus robots, So let's say you wanted to build a factory. Then Grok could organize the Optimus robots, assign them tasks to build the factory to produce whatever you want.
Don't you need to merge XAI and Tesla then? Because these things end up so...
What were we saying earlier about public company discussions?
We're one more Guinness in, Elon. What are you waiting to see before you say we want to manufacture 100,000 Optimuses? Is it like
Optimi? Since we're defining the proper noun, we can define the plural of the proper noun too. So we're going to proper noun the plural, and so it's optimi.
Okay.
Yeah.
Is there something on the hardware side you want to see? Do you want to see better actuators, or is it just you want the software to be better? What are we waiting for before we get like mass manufacturing of Gen 3?
No, we're moving towards that. We're moving forward with mass manufacturing.
But you think current hardware is good enough that you just want to deploy as many as possible now?
I mean, it's very hard to scale up production.
I see.
But I think Optimus 3 is the right version of the robot to produce maybe something on the order of like 1 million units a year. I think you'd want to go to Optimus 4 before you went to 10 million units a year.
Okay, but you can do 1 million a year at Optimus 3.
Yeah, I mean, it's very hard to spool at manufacturing.
Yes.
So like manufacturing, like the output per unit time always follows an S curve. So it starts off agonizingly slow, then it has this sort of exponential increase, then a linear, then a logarithmic outcome till you sort of eventually asymptote at some number. But Optimus initial production will be it's going to be a stretched out S curve because so much of what goes into Optimus is brand new. There's not an existing supply chain. As I mentioned, the actuators, electronics, everything in the Optimus robot is designed from physics first principles. It's not taken from a catalog. These are custom designed everything, literally everything. And I don't think there's a single thing I've done.
How far down does that go?
I mean, I guess we're not making custom capacitors yet, maybe, but there's nothing you can pick out of a catalog at any price. So it just means that the Optimus S curve, the units per output per unit time, how many Optimus robots do you make per day, whatever is going to initially ramp slower than a product where you have an existing supply chain. But it will get to 1 million.
When you see these Chinese humanoids, like Unity or whatever, sell humanoids for like 6K or 13K, do you just are you hoping to get your Optimus's bill of materials below that price so you can do the same thing, or do you just think qualitatively they're not the same thing? Like, what do you think is going? Like, what allows them to sell for so low, and can we match that?
Well, our Optimus is designed to have a lot of intelligence, and to have the same electromechanical dexterity, if not higher than a human. So, Unity does not have that, and it's also, I mean, it's quite a big robot. So it has to do carry heavy objects for long periods of time, and not overheat or exceed the power of its actuators. So we've got it's 5'11", so it's pretty tall, and it's got a lot of intelligence. So it's going to be more expensive than a small robot that is not intelligent,
but more capable.
Yeah, but not a lot more. I mean, the thing is, over time, as Optimus robots build Optimus robots, the cost will drop very quickly.
And what will these first million Optimi do? Like, what will their highest and best use be?
I think that you would start off with simple tasks that you can count on them doing well.
But in the home or in factories, like...
The best use for robots in the beginning will be any continuous operations, any 24/7 operation, because they can work continuously.
Yeah. What fraction of the work at a gigafactory that is currently done by humans could a Gen 3 do?
I'm not sure. Maybe it's like 10-20%. Maybe more. I don't know. We would not like reduce our headcount. We would
for sure
increase our headcount, to be clear.
Right.
but we would increase our output. So the units produced per human, like total number of humans at Tesla will increase, but the output of robots and cars will increase disproportionate, like much to number of cars and robots produced per human will increase dramatically, but the number of humans will increase as well.
We're talking about Chinese manufacturing a bunch here, and we're also talking about, we've talked about some of the policies that are relevant, like you mentioned, the solar tariffs.
Yeah.
And you think they're a bad idea because, we can't scale up solar in the US.
Well, just the electricity output in the US needs to scale up.
Right, and it can't without good power sources.
You just need to get it somehow.
Yeah. Where I was going with this is, if you were in charge, if you were setting all the policies, what else would you change? So you change the solar tariffs as well.
Yeah, I would say anything that is a limiting factor for electricity it needs to be addressed, provided it's not very bad for the environment.
So presumably some permitting reforms and stuff as well will be in there. Yeah.
But there's a fair bit of permitting reforms that are happening. A lot of the permitting is state-based, so. But anything, but this administration is good at removing permitting roadblocks. And I'm not saying all tariffs are bad. I'm just saying because I think
solar tariffs. Yeah.
So yeah. I mean, sometimes if another country is subsidizing the output of something, then you have to have countervailing tariffs to protect domestic industry against subsidies by another country.
What else would you change?
I don't know if there's that much that the government can actually do.
Well, one thing I was wondering is, it seems like for the policy goal of creating a lead for the US versus China, it seems like the export bans have actually been quite impactful, where China's not producing leading edge chips and the export bans really bite there. China's not producing leading edge turbine engines, and similarly there's a bunch of export bans that are relevant there on some of the metallurgy. Should there be more export bans? Like, you think about things like, there are now the drone industry and things like that, but is that something that should be considered?
Well, I think it's important to appreciate that in most areas China is very advanced in manufacturing. There's only a few areas where it is not. China is a manufacturing powerhouse next level. Like, people don't. Most people.
It's very impressive.
Yeah. I mean, if you take refining of ore, I'd say roughly China does twice as much ore refining of on average as the rest of the world combined. And I think there's some areas, like, say, refining gallium, which goes into solar cells. I think they're at 98% of gallium refining. So China is actually very advanced in manufacturing in I'd say most areas.
It seems like there is discomfort with this supply chain dependence, and yet nothing's really happening on it.
Supply chain dependence?
It depends on, say, the gallium refining that you're saying.
Yeah. There's a
all the rare earth stuff and.
Yeah, rare earths, which are, as you know, not rare.
Yeah.
Like, we actually do rare earth ore mining in the U.S. Send the rock, we put it on a train, and then put it on a boat to China. That goes on another train, and it goes to the rare earth refiners in China, who then refine it, put it into a magnet, put it into a motor subassembly, and then send it back to America. So we're really missing a lot of ore refining in America. And
isn't this worth a policy intervention?
Yes. Well, I think there are some things being done on that front. But we kind of need optimists, frankly, to build ore refineries.
So you think the main advantage China has is the abundance of skilled labor, and that's the thing optimist fixes. But then also we need
China's got 4 times our population. So.
But we need. So I mean, there's this concern, if you think humanoids are the future, that right now, if it's the skilled labor for manufacturing that's determining who can build more humanoids, China has more of those. It manufactures more humanoids. Therefore, it gets the optimized future first. It just keeps that exponential going. It seems like you're sort of pointing out that sort of getting to 1 million optimi requires the manufacturing that the optimi is supposed to help us get to. right?
You can close that recursive loop pretty quickly.
With a small number of optimi.
Yeah. So you close the recursive loop to help the robots build the robots, and then we can try to get to tens of millions of units a year. Maybe if you start getting to hundreds of millions of units a year, I think you're going to be the most competitive country by far. We definitely can't win with just humans because China has 4 times our population.
Right.
And frankly, America's been winning for so long that we, just like a pro sports team that's been running for a very long time, tend to get complacent and entitled, and that's why they stop winning, because it's don't work as hard anymore. So I think frankly, just my observation is the average work ethic in China is higher than in the U.S. So it's not just that there's 4 times the population, but the amount of work that people put in is higher. So you can try to rearrange the humans, but you're still 1/4 of the assuming that the productivity is the health is the same, which I think actually it might not be.
Yeah.
I think China might have an advantage on productivity per person. We will do 1/4 of the amount of things as China. So we can't win on the human front, and our birth rate's been low for a long time. So our birth rate's been the U.S. birth rate's been below replacement since roughly 1971. So we've got a lot of people retiring, or more people dying than we're close to sort of more people domestically dying than being born. So we definitely can't win on the human front, but we might have a shot at the robot front.
Are there other things that you have wanted to manufacture in the past, but they've been too labor intensive or too expensive, that now you can come back to and say, oh, we can finally do the whatever, because we have Optimus?
Yeah, I think we'd like to build more ore refineries at Tesla. So we just completed construction and have begun lithium refining with our lithium refinery in Corpus Christi, Texas. We have a nickel refinery, which is for the cathode, that's here in Austin. And these are the largest. This is the largest cathode. This is the largest cathode refinery, largest lithium refinery, the largest nickel and lithium refinery outside of China. And it's like the cathode team would say, like, we have the largest and the only actually cathode refinery in America.
Many superlatives.
Not just the largest, but it's also the only. So it was pretty big, even though it's the only one. But I mean, there are other things that you could do a lot more refineries and help help America be more competitive on refining capacity. So there's there's basically a lot of work for the Optimi to do that most Americans, very few Americans, frankly, want to do. I mean, I've actually.
Is the refining work too dirty, or what's the?
It's not. It's actually no. We don't. There's not. We don't have toxic emissions from the refinery or anything. The cathode nickel refinery is right sort of in Travis County, like 5 minutes from to.
Why can't you do it with humans?
No, you can. You just run out of humans.
Ah, I see. Okay, yeah.
Like no matter what you do, you have 1/4 the number of humans in America and China. So if you have them do this thing, they can't do the other thing. So then. Well, how do you build this refining capacity? Well, you could do it with Optimi, and not very many Americans are pining to do refining. I mean, how many of you run into? Very few.
What are you?
Very few plan to refine.
BYD is reaching Tesla production or sales in quantity. What do you think happens in global markets as Chinese production in EV scales up?
China's extremely competitive in manufacturing, so I think there's going to be a massive flood of Chinese vehicles and other basically most manufactured things.
We're going to stop it right there.